Hello, everybody. My name is Shreyas. I'm a member of IEEE PES DSCE student chapter at Dayanand Sagar College of Engineering. We are delighted to welcome you all for the IEEE PES DSCE student chapter YouTube channel and to this podcast where we will be interacting with Dr. Deepak Tandur. Dr. Tandur is a principal R&D researcher at Hitachi Energy and a senior member of IEEE who actively participates in standardization work groups. He also serves as an executive committee member and a secretary of IEEE Energy Publicity Society. Prior to joining Hitachi Energy, he worked as he worked as a senior scientist at ABB for 8 years. Dr. Tandur has over 10 years of experience in industrial research and holds a PhD degree in electrical engineering from KU Leuven in Belgium, with a focus on wireless communications and signal processing. He also has a master's degree in embedded systems design from Elri University Switzerland and master's degree in software engineering from Scuola Superiore and Italy. If I've made any mistakes with the pronunciation, I'm sorry. Dr. Tandur has authorized over 40 peer-reviewed papers and has over 10 patent applications to his name. We are privileged to have him join us, and we are sure that we'll learn a great deal from his immense knowledge and experience. Uh, Thank you to we are we are really glad to have you, sir.
I'm very glad to be here. Thank you for inviting me. It's always great to connect with students and discussing with them. Yeah, I'm very happy to be here.
So first off, I'll start off introducing everyone in the meeting. I am Shreyas. I am a second year student of Dayanand Sagar College of Engineering. Uh, Along with me, we have Punit. He's a third year student of Dayanand Sagar College of Engineering. We also have Sirisha who is a classmate of mine, second year Dayanand Sagar College of Engineering, and Maulya, who's also a classmate from the same class.
Hi all. Hi everyone.
Hi, sir.
Yeah, nice meeting you all.
Sir, please tell us about your journey in the IEEE PS and its role in your personal development, personal and the professional development.
Yes, definitely. IEEE PES society member is quite recent for me. I've been its member for last 4 to 5 years only, and but I have been part of IEEE much longer, around 15 years or more. So since I've yeah, so PES is also because this society because it's part of the my company's business where I belong, Hitachi Energy, is focusing on is focuses more on electric energy and electric distribution, generation, and so on. So it was very natural for me to also get into to become a member of this society, PES society. So I have always been, as I said, been part of IEEE, and which have always you can be a member of any society within IEEE, which allows you to grow professionally, network with uh, community members from within that society, helps you to develop and understand the challenges, questions in that particular society at that point of time. So in that context, I became part of the PES society, and it has definitely, since my company's business is also in grid business, and this always extends my knowledge, learning beyond what is within the organization, what you learn within an organization, and it's you get to interact with students in the electrical field as well as professionals, and so it has been a very it has been a good learning experience, and I've become. I was also secretary last year, and which allows you to IEEE allows you also. Apart from your own organization where you work or study, it allows you to inculcate leadership quality as well. When you are part of these societies and you actively take part as executive member, be it in a professional society or in the student chapter within your academia. So it is, I always encourage all the students to actively participate in IEEE.
Sir, I would like to ask what motivates you to become an R&D engineer? Like, is there any particular experience or a person who motivates you to pursue this career, or it's your keen interest and passion towards science and technology?
So I think Sirisha, you answered the question. I very much connect with the second part of what you said. So it is a person should look within themselves and see what is your interest, and for me personally, I was always very interested with science and technology and exploring different kind of technologies, and doing hobby projects. So this was so it was always for me. It was engineering as a profession was very is something that I always I well as a when I was growing up as a student, I did like all of us. We don't know what to study, but this was something that I was quite fine with, and I was as during the college. I was also I enjoyed uh, and different subjects. And so when I passed out of bachelor's and then I went on to do further studies in masters, then so then the interest always continued. And then there was always a possibility to move to take up a job, but I always somehow there was always an interest in doing further studies and further exploring the subjects that I was interested in. So then it was about after master, it was about doing PhD. So then by then it dawns on you that looks like the research is something that is very something that excites you. So it was completely an own uh, inner call, you can say, and that continues even now. So so it is up to a person to determine what is right for him or her. And so that would be what I would suggest everyone.
Sir, what kind of skills and knowledge you think are essential for someone who's starting out a career in R&D engineering and science?
So definitely in this field, one has to be open-minded, and that's one of the skill, or you should always be. That's the kind of mindset you should always have when you are in R&D, because you're always looking at trying to solve a problem which is something new. A problem exists, or it is, or we can also see that because of certain uh, we can expect that a certain problems may occur in the future, and then you are trying to figure out how that problem can be solved. So that so if a problem is already solved, it will not be part of R&D. So it would already be it is already solved. So that's why that's the mindset you have to be always cultivate. That is an open mindset, looking at the problems, and then if the problem exists, trying to understand how why that problem has come, why it exists, what are the possible, and then you study the problem in more detail, and then you work towards trying to find an answer what can contain that problem or how you can solve it. So one of the main skill set is, of course, being very open-minded, being ready to take these kind of challenges, and not be curtailed by exactly looking at the solution that you have learned earlier. the solutions that you have learned, the skills you have developed in your college in the during engineering, they form as a very good platform basis from which you can start. You need to learn, or you need to develop skills to solve the practical problems of what exists today. And yeah, so you cannot stop with what you have learned. It's a continuous learning process, and that kind of attitude a person should be open about while taking up an R&D career. I hope that answers.
Yes, sir, definitely.
Good morning, sir. Sorry, good afternoon. I'm Maulya. So my question will be for someone who has to choose between academia or R&D to set up an industry, what are the points or criteria that he or she have to think of?
Yeah, so once again, I would say it's completely on one own and what interests you, and whether the academic life or the industrial life. Now, the question is, how do you determine what interests me? Because while you are studying, yeah, both may look very similar, or we do not have like we do not know what is it on the other side, the industrial side. And so one way, what I would suggest, what I felt was, what can be a way to look at this thing would be to focus more on the problems or the projects that you are getting. You're getting, if you are with an R&D, you have an R&D mindset. So what matters is the kind of work that you are going to do. Is whether that work, it could be in the academia, academic research, or it could be in the industry. Now, is that work, is it the work that you are going to take up, or the subject is that something that interests you? And yeah, so so based on that, whether that work will help you, is it something that excites you to solve that? And the work eventually has to be relevant, whether you do that work in academia or in industry. And the how, and yeah, so the relevance of that work, uh, you should look at. And if it is something that makes sense to you, it is a good project, it could be anywhere in academia or in industry, and then you can follow on that. So I would say it's very. There are many of my colleagues, and I know my friends who have switched between academic life as well as industrial life. They work on both sides, and what motivates them is are the projects that they work on. And it really doesn't matter whether on which side you are working on. So it is more about the work, and for some people, whether this work is bringing relevance, bringing goods, is solving a significant problem that you are connected with, and that's how they decide. That's how they go. So for me personally as well, I do not see much of a difference as long as the work or the project that I'm involved with, and if it is something that I can get connected, I feel engaged with, is all that I look forward to.
It's actually a nice way to put it that a type of project is defined by your interest or the creativity you have. But my question is basically like, even if it is a academia or in the industry, the main thing for a project is a problem statement. How can we like get to a point where we can search for more problem statements for a good project? It is always a big dilemma for the beginners like me.
Yeah, yeah, yeah. So look for problems. Of course, we all go to internet to look at what other problems are being given in one university, or in a particular college or wherever, and pick problems that you think are more relevant. And that, yeah, once again, like that connects with you, and then so that connects with you, and you know that this is a good problem to solve. It's not something totally, it's not very abstract. And if something is very abstract and you are get into that project, then you just are doing to complete that project. You are not doing it. Yeah, so it will not help you with lot of with learning. But if it is something that you think it's a good meaningful work project or problem statement, where the problem is also relevant in the real world, and if you can solve that problem, it can help something in the world. Like, okay, as a student, the same problem is been looked by or like in by many students in different colleges, different universities. But that's okay. What if you think that problem statement is a good, relevant one, and it can help? It looks like at least it addresses some of the real world problems. Then that can be a good problem statement to take, instead of taking something which is not much relevant. See, in college life, we may get problems which no longer is relevant, coming from the old times or old. Yeah, so you need to always pick up problems where which is meant for today's practical world or tomorrow's, especially as an engineer. So you cannot pick up some problem from working on some old technology and which is not relevant today. Okay, so that could be one way of looking at it.
Tell me about the project which you have worked on and you faced, which is more interesting and challenging at the same time, and what are the technical challenges you have faced while working on that project?
Yeah, so maybe I can. One of the recent projects we were working on was to ensure that uh, the was to help the design engineers make the design much of the particular problem, like in the grid design, and for them to ensure that the design becomes much easier. The computer, the we can use of machine learning methods or with the previous learning that can help them to give them a certain template of the designs of of the communication network which overlaps with the grid. Now that was a very interesting problem because we looked in the grid. We were mainly focused on substations, and substations have a certain particular design, and the communication network goes on top of that. Now we had to learn. We wanted to learn the different templates of how these communication network in a substations are designed. And so this involved learning of different types of different possibilities of network design. And yeah, so here machine learning was very helpful, and giving them a template. And then of course the engineer need to make his or her decision whether the template that is being given for a particular grid, is it making sense to them or not. Can they also adapt it? Can they give instruction back to the software that what the template that has been provided to them, is it meeting their requirements, or something else needs to be added? So an engineer would just provide those inputs in a high level language. I want in a certain part of the network, I need to meet a certain bandwidth requirement, or I need to ensure that there is a sufficient amount of availability in certain part of the network. And then at that kind of input, they will give it back to the software, and the software needs, based on their inputs, needs to uh, convert that high level instructions into the design instructions for the network and come back with a new network. So that was a very interesting project, and which which was which goes which it requires communication engineering as well as understanding also the grid or the within the substation. So how the substation works, and on based on that, the communication layer has to work on top of that. So it was a very interesting project. Uh, that we did that we worked on recently.
Sir, how do you manage the need for innovation and project deadlines at the same time? Like, how do you approach the risk management factors?
Yeah. It's a very good question because we live in a structured timeline uh, based system, and we for students, even if you like a certain particular, let's say you like a particular subject or you're working on certain project, you love that project, but then you need to meet the deadline. You cannot be you have a the semester ends at certain point of the in at certain point of time, and then you have to submit that project. And so that's uh, and many times you would like it's possible that the project that you are working on, you're very interested, but then yeah, you have to meet the requirements, close it, because that's how we live, and we finish, and we need to give it because there is a reason, there is a certain deadline. As a student, there are semesters ends, and in industry, customer needs that kind of solution. And so that's the practical need, and then you need to ensure that uh, though you may like, you are maybe interested in the entire project or in a certain aspect of the project, but once you submit that project, you always have some learnings from that project. and and if you love that project, you love the innovation part of it, you take those learnings into the next project that you are going to get. So it's if you really love that project, certain aspect, you can definitely always inculcate, do it in your own time. It becomes a hobby because you just love that particular whatever you are building. So you may not care for the deadline, but and you may just continue working on it. But, yeah, so you need to ensure that if you love something, of course you should be working on it. You should never stop it. And yeah, but since we live in a deadline kind of society, because we need to deliver it, we deliver packet, whatever you have built, give it. And if you love working on certain thing, you just continue working on your spare time, on your in your free time. And since it's something you love it, it doesn't feel like work because it's something that you just like. So yeah, so it will over the period of time. So I think that if you like love R&D, you love building things, then you will have many such interesting act part projects you will get in your life, and that you will just like to build on your build it or work on it, irrespective of deadlines.
So what advice do you have for a person who is just starting out his career as R&D engineer or in in the field of science?
Yeah. Yeah. So it. Yeah, so the first question is the person should ask themselves why they have come to this field. Is it out of their own interest, or is it because of societal external from the external input like parents, or because you get a job, and because of those aspects you have come in. And I would, okay, even though we parents and it's, we they guide us, okay, this is a good career path, and we might have ended up in this career path, but it's very important to look it to see it yourself. And because that will help you to then uh, then that will help you how you can move ahead. And if you, though you might have come into this career path by accident, I don't know, maybe you like it, and but it is it's you need to see what are the part aspects of this career path, science or R&D, that are interesting, which you like. It's very important to identify what you have liked, or what you have liked so far, and the subjects what you are studying, what you like in them. And because that will make your career or your studies lot more enjoyable. And you need to you need to like, you may not like all the subjects that you have. It's possible that you like only few of them, but it is important to identify and appreciate and enjoy those subjects, because as you go into your third year, final year, you may want to take your thesis, and you may like to have take a thesis on a topic, on a subject that you are more interested in. So I would always suggest students to looking for the subjects that they like, because uh, you should be, then you will give a, then you will do a much better job in whatever thesis or projects that you get, not just in the college, but once you are out of college also, and you will do a much better job in those projects, and which will also give you much satisfaction, because you did a good job.
So in today's growing world towards advancement, how do you keep yourself updated with the current advancements in your particular domain?
Yeah. So actually, this question is the first step in any project that we take in R&D. So any topic project that we get, and we need to see. Uh, well, all the problems that we get are, as I said earlier, are something new, because once you are in industry, it's always a new problem that needs to be solved. A problem that is already solved doesn't come to R&D, and so any problem that comes, it's the first step that you need to see, learn about the problem, what is there, and then you also need to have a survey of that particular, how that problem has been looked at in general, and what are the and so you need to do a proper survey online, understand are others also solving that problem, how others have looked into that problem, and when you start doing it, you will automatically, you will see, you will learn all the state of the art technology being used to solve that, to at least look into that problem, to solve that problem. So this is the first step, and with that step itself, you become updated with what is the latest in that particular area, what you are looking at, and yeah, so that's the first step that you must do, and for any project that you take up, you know what exists, already exists. You don't need to reinvent the wheel. If things already exist, you can just use that solution. If it's an open source solution, you can use it, or yeah, and if the solution, yeah, and only or solution exists, you need to fine tune it for your problems. And if there is nobody has looked into it, it's something very new, new problem, then take it as an opportunity, because you will be coming up with new innovation solution for that problem.
So when you're taking up a problem statement, what is the first step that we start with that problem? How do we grow? Like how do we develop using that problem statement?
Yeah, so the problem statement is, yeah, depends on, yeah, let's say you want to take up an IoT problem statement, and now you, let's say you want to develop, the problem statement is you want to ensure that the IoT solution that you develop, it provides that answer. It is measuring. It's for the road traffic. It is measuring different parameters from the road, different weather conditions, the road condition, traffic condition, goes to the cloud and gets information, comes back to the driver in that road. I'm just making up this problem statement. Now, yeah, so you need to understand the different aspects now from different angles. What all different parameters you need to pick up, which makes sense for the driver in that car, and which will help that driver. So, what are the things that can help the driver? Is the weather condition fine? Is the traffic very bad? The driver would also like to know. These are all the external information. The driver would probably also want to know the vehicle's parameters themselves. The tires are okay, engine, everything is working, And all this, if you have to take it to the cloud, bring it to his or her phone or the dashboard in the car, then yeah, so you start looking at the problem with from what will eventually help the driver, because all the solutions finally has to help a person, and what are the things that person would need. So this person is, yeah, so this person is a final, yeah, there can be one driver or there can be 100 drivers on that road, and you need to see what would matter to this person. And then from there, uh, you see if all this information is available to the driver, and the driver gets the alarms and events at the right point of time. Somebody is speeding very high, is speeding, and then or that driver itself is speeding, and then some alarm has to be given or message has to be given. So you look at it from all those aspects to create all the problems. In that problem statement, you create all the parameters that the driver would be needing. And once we know, yeah, these are a good set of problems, 10 parameters that a driver would need. Now for each parameter, you need to then see how that parameter can be given to the driver. Now a particular, like whether the traffic conditions are bad, now that how will we get solve that problem and give to the driver. So you can actually, yeah, so that's a question now. How will a driver get to know if the traffic is bad in front? Easier answer would be, yeah, so just collect it from Google Map and see if it is red, and then say after 500 meters, it is, just show him the Google Map. Or if the driver can't see the map, you have to say within 500 meters, you will be getting this kind of traffic is going high. Probably, yeah, Google Map itself can do it. But then, so similarly, you need to see whether this solution already exists, or we need to give how we need to find out the answer that the driver needs, in what way we can give it. And sometimes the answers are very straightforward, sometimes we need to work on it. So, but it's important to see, we shouldn't be working on answers that already exist. We should be looking at answers, problems which requires, which actually the answers are not, where the answers are not available today. Then then the job for the engineer comes, because we need to fine tune something, work something, and give the answer. Okay, so that's how you can start. You do the reverse engineering. Because you look at the final person, final what needs, problem statement, and then you work how to come to that problem, how to provide answer to that problem.
What are the career opportunities in digital signal processing?
Oh, signal processing is a very wide and subject, and you could be involved in audio signal processing, video signal processing, or communication signal processing, and it also provides a platform for neural networks, machine learning. So everything is getting, all the signals get processed somewhere, and so the digital signal processing becomes one of the basic subjects, which can, and understanding this subject can help you to gives you a good foundation when you go further in any particular uh, any particular subject. So subject within signal processing, and it's very wide. It encompasses uh, all the different mechanical, electronics, computer science, uh, or you can say it's a subject is fundamental. So it impacts all the different subjects, all the different streams, and yeah, so opportunities are there for from DSP. It comes in each and every subject. So you can be interested in software side, or you could be interested in the hardware side, and interested in how you can process certain information in the hardware signals. And yeah, so it depends on what is the direction you want to take.
Sir, what are the recent trends in the smart grid?
Recent trend in smart grid is you see everything is changing to electric power. So I'm sure some of you have electric vehicles, scooters, and so on. So EV is one of the big big factor driving the smart grid, uh, as well as as well as renewables, uh, uh, individual power generation capability in at homes, and from the grid side, connecting all these and bringing it to the grid. And so there is a lot of importance also from the digital point of view. That is about monitoring the flow of electricity, and also different controlling and protecting the different components within the grid. When in the scenario now, when we have so many EVs coming up, renewables uh, sources coming up everywhere, and so the grid is no longer straightforward thing like the electricity being generated in some faraway place and being distributed in cities. Now the town cities, individual homes are also generating electricity and giving it back to the grid. So, so there is a huge scope for engineers who are looking to work in this area, because everything is moving to electric power and and greener power.
Oh, sir, you have written over 40 peer-reviewed papers and also you holds over 10 patent applications, which is really very phenomenal. Oh, many students will be working on their ideas in their college life. How can they apply for the work how can they apply for the patent for the work that they have done?
Yeah.
Can you just brief about that process?
See, it helps a lot in patent if you are working with industry. And it's very there is it's about even universities themselves, they also make they also file patents. And it's about yeah it's but it becomes it makes more sense when it happens in industry. It's because something they want to keep protect their protect the solution that they're bringing to the market. So patent is about protecting that whatever solution you are bringing to the market, so that competitors cannot copy the same thing. And you have an intellectual property on that particular solution, and then you have the right for certain number of years from law, and then you are the only sole provider of that solution. It is to help companies to come up with newer solutions and protect. It gives them when they bring to market, so others don't trespass on those, but those do the same solution. So that's why in industry it makes more sense. Like I feel universities also create patents, and yeah, so it depends on what is the reason of filing a patent. And from academia, it is academia's focus is more about distributing knowledge, and it is so in academia the more interest is always in publication, which can which is for yeah which is about distributing knowledge and for everyone to learn about it. Now, patents is a different. It's a different track where you are protecting whatever you have developed, and I think uh, the when as a student, once you pass out, you join industries, R&D organizations, then you will see uh, focus more on patents. And it is about so it could be any solution. It need not be a very difficult solution, but as long as the solution is something the company thinks they need to protect, they need to keep it only, they don't want others also to use that for their advantage, it can company can go and find a patent. and it's something that it's an expensive process. It has to make market sense. Then only the companies go and pay for the patent, because the company needs to file it and then pay for its processing and maintain that patent, pay for its maintenance every year. Whether it's an Indian patent or US patent, and they need to take the expense of maintaining those patents every year until that patent can expire. So that's why it is more. It happens mainly in it's mainly the industries that look into patents. So as a student, if you get an opportunity to work in a project and which is coming up with a newer solution, and that can happen mainly with industries, and they can people from industry can guide, and it is their objective. Industry, if your project is with certain industry, it will be that industry's objective, and you can contribute to that particular solution, and then the company, that industry or that company goes and files the patent.
Thank you for the information, sir.
No problem.
So basically, when it comes to projects, the main thing after the problem statements would be the teamwork or the team which you make. When you're a leader, you're basically you'll have that liberty to make your own team. So what would be the main qualities or the things you would see while making a team for yourself?
Yeah. So in a team, of course, there should be a good team spirit. Okay. Someone could be, what we always want is a good, uh, though as individuals, we all may not be, everybody is good at something and may not be good at other things. But as a combination of a team, the the team should be, first of all, the members should have a good team spirit to work with each other, to help each other, to and always keeping the objective of the problem in mind. So everyone understands the problem very well, and the problem statement, what the team is trying to solve it. Okay, and then based on that, if it is, there is a good clarity on the problem statement, the different problems that makes up that problem statement, the things that needs to be worked on, and then then the work automatically get distributed amongst the team members, provided that team members have a good uh, there is a good collaborative spirit. So everyone takes up a different task by themselves, and these tasks need not be very strict. And as the work progresses, uh, it is possible that everyone is helping each other or doing a different aspect of the work, and the work aspect also can change. But then always it is important to keep the final objective in mind, what the team is supposed to deliver. So in a thesis, if you have, like, someone is supposed to work on hardware, someone is working on software, someone is not working on, yeah, so different aspects, then but the two members on this and two members on the hardware side. So it doesn't mean that someone who has picked up hardware from the beginning does not cannot help the software person. So it is eh, yeah, so it's, yeah, the person who is working on the software side, coding side, everyone respect that person is working on the coding side and reading that, and then others also understand what that person is doing, and then that person needs some help or some learning, then everyone is helping that person. And it's a collaborative spirit that is the most important in a teamwork.
So how was your very first research paper? How was the experience of publishing it?
Yeah. So the first research paper is always the most difficult one. So my professor, he always he always told all the students, uh, this is during the PhD time, that the first paper is the most difficult one, and but the guide, you need help. Guide plays a very important role in helping a student uh, conceive the paper and to write the different parts of the paper. And a guide plays a very important role because the guide is also a reviewer and helps in improving the quality of the paper and the story that you are writing in that paper. So it should, of course, if you're writing a research paper, it should be something novel. It's a part of your. It may be a very novelty, may be very small, but it doesn't matter. But you are bringing in some new aspect in the paper that has not been spoken about it anywhere else. Though it is a small aspect, maybe it's a practical work, you are putting it in the paper, adding it in the paper. Let's say you deployed a network, you deployed a Wi-Fi network in the campus, and you are looking at the performance of the networking within the campus for a certain, let's say, yeah. So, but the aspects that you talk about in the Wi-Fi coverage within the campus is of its performance aspect, or some, like, it has to be something new in the paper, and whatever it is. So uh, the reason being, when you write a research paper, you are as you are a researcher, and you are contributing towards pushing the or pushing the knowledge of the research, of the research community. The paper is not just for you, but the paper finally goes in platforms such as IEEE Explore, and it's available globally. So it has to be something. Whatever you put in the paper has to be something. It has to have a new additional quality in it. So that's why the guide plays a very important role. Survey plays a very important role, and the what you write in a paper needs to be told in a sufficiently uh, detailed manner so that the reader understands, and that helps the reader to move ahead with the results that you have given. So we write you when you write a paper, you refer many other papers, and from many other papers, you add your own additional element and you make your own paper. So similarly, this paper is now going to become part of the paper ecosystem, and somebody else, next researcher, is going to also refer to your paper along with others, and uh, will write something new on top. So basically, as a researcher, we are all pushing the boundary of science. We are all putting something new, contributing new to science. So of course, if you look from this point of view, it's a having a paper what you have written is, first of all, if you submit it to a, let's say, conference or a journal, it getting accepted, that itself means there was some new quality in that paper. And as a first person who is starting out in this area, of course it will be, it's a great time to celebrate. It makes, of course, you have contributed something to science, you can say, of course, because the paper has been accepted. So that and and hopefully that also motivates the researcher to continue working in that, continue to do research, and and contribute towards publication, further publication. So when I started my journey, of course, the first paper that I wrote, it involved the guide's contribution was very important. The professor's guidance was very important, and then and it takes hard work, because you have to understand how the papers are written, and once you understand it, and then on the second paper, third paper, it's much easier how to put material for the paper and then submit it.
Okay, sir. Like it is said that nowadays the many software developers were asked that what if the AI takes over your job? And I don't think so. AI will help the R&D engineers much in accuracy, and it will provide the accurate data. Does it really affect the R&D engineer, or what are your thoughts on that?
See, every technology only pushes the capability of people, of humans. When if you can make, as a researcher, it is always good to go to the extreme case as a researcher. Okay. Now, okay, let's say today's extreme case is the AI, which is able to give us great answers. But also, we should turn it the other way. When we didn't have any technology, and when the first time somebody built a wheel or somebody built an axe to cut something, then it created a lot more jobs. When somebody built an axe to cut it, people started farming, and became that became a profession. And where someone made a wheel or somebody made a car first time, and it created more jobs. Similarly, every technology, it just advances humanity, and AI similarly also advances humanity. It is something that finally all the technologies are meant for humans only. So humans only make the decisions, and we, let's say, even the AI, we are using AI also to make decisions, but AI eventually the final decisions will be resting on humans because it is to serve humans, and we use AI as we use it as a tool to give us quick answers, to help us already provide something like to do a problem statement survey search. It can give us great search results, and then finally, as a person, you only have to make a decision. The result that AI has given, does it make sense or not? And you need to fine tune on top of it. Earlier, you had to do more manual search on the search engines, but now that has reduced. That work effort has reduced. So as AI advances, we use these technologies, and to assist us, to assist humans, and we go beyond. The only thing is, yeah, we are all, every technology can be used in a good way and a bad way. This technology will also be used in good and bad way. There is but eventually people understand if there are bad ways of using the technology. Regulations come in with every technology, whether it was nuclear or anything. uh, every Slowly things start getting regulated, and that's just a part of a cycle. And the good things, forgetting, let's keeping the bad things aside, the good things will help boost to solve the millions of problems that exist on the planet. The computers, the AI will help us to, if you see the book, there are huge number of problems that exist outside, infinite problems, and it will help us keep solving problems, making the world a better place. So you go outside your room now or outside the college, you can definitely see there are a lot of things that are not fixed. It's just, it has nothing to do with AI, but what I just want to say, in practical, the world we live in, the world has a lot of mess, lot of things that are not fixed, and this one more technology will help us to fix certain parts of it, and it's just a continuous. It's just a continuous movement where we are what we are continuously trying to improve our living, and this technology will also help us in improving our living. There will be bad aspects for sure.
Sir, is there any necessity, experience, or previous knowledge to get into R&D, or only the skill matters?
So skill will just take you to only a certain distance, whatever skill that you have, and you need to pick up new. So you need to be completely open-minded with every research or development project that you get. And so any project that you get, the things that you have learned, the skills are that gives you a platform. And every project you will have to learn new skills, and so you should take that as the interesting aspect, because you will always be learning new, something new always and yeah, so that aspect should always excite you, and it is never the same thing that you are doing. and you are always learning and moving forward. Let's say you can say if you are doing exactly the same thing, you may feel things are monotonous, but in R&D life, things are never still. It's always uh, it's always moving. So what matters is you keep growing your skills. Some skills will get outdated, and you are open to uh, learn and adapt new skills. And for that, what matters is your mindset. You're open to learning and open to apply the learning for the problem that is in hand.
So today there's a lot of boom that tell that there's in the embedded systems field. So everyone tell that when you're choosing something, go for VLSI or embedded systems. You have done your masters in embedded systems, so a little brief about the career options that we can have in the embedded systems.
See, embedded is also, yeah. I think if you look at IoT devices, just search IoT devices in 2020. I think it will give you some number, some 10 billion. And IoT devices in 2030, it will give you, I think, 3 to 4 time factor. Just do a search. Every IoT device is an embedded device. So we have embedded devices everywhere. The ones that you have put in your ears, it's an embedded device. So yeah, you have and it just keep growing, the number of devices that we have, the connection that we are making between different devices, different entities, uh, and yeah, it will keep growing. And so there is it's so now what matters is every subject has a good career path. There is nothing uh, 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 that would limit you. Only limitation is from you yourself. If you love that subject, you like embedded and certain aspects of embedded, I don't know whatever it is. I prefer communication. That's what I took up. And yeah, so you will they will and so that particular aspect you can keep uh, developing yourself into. So every what matters is the as an if you want to take career in R&D, you should know these are the areas that I like it, I'm enjoying it. There may be newer areas that you may start liking it, and keep yourself curious and keep and you should like to solve problems. And if you have that mindset and career options doesn't like whatever subject you take, it really doesn't matter. All the subjects finally interlink with each other. It's not like if you take embedded and I will never do any any software aspect, or I will not even do some management aspect. As you grow, you will have to do management. You have to deal with management related areas. So you should just be open. It just expands your another horizon in your mind. So that's how you just take it. But if given an option, always pick a subject that you love, you enjoy, and go ahead with it.
So I'll ask a really common question which you'll be getting a lot. When you're interacting with students, of course. My question is basically, if a fresher wants to connect to you online or either in person, how can he approach you?
Yeah, so uh, I think if you are in Dayanand College, you know Professor Satish, so you can. So that's an easier way. And I'm yeah. If you know my profile on LinkedIn, you can always drop a message there. And yeah, so I think it's much easier these days. And anybody you want to talk to, and yeah, it need not be just be me, but any profile that any person you like or you want to talk to. I think it is possible to start initiate it via one of those online platforms. Uh, and yeah, so I think being a Dayanand college student, and then Professor Satish is he is a very active IEEE member. I'm also in IEEE. That's another platform. Being actively involved in IEEE, and PES is an area that interests you. Being member of PES student chapter and organizing events in college, so you can get more professionals coming and talking to students. So there's yeah, those are the different ways, and I'm sure you can students can if you sit together, you can figure out some 10 other ways to to bring professionals, to get access to them, to talk to them. So yeah, uh, yeah, that I would say that, of course, once you are connected to with the person over, let's say, LinkedIn, or then you can always question them, ask them for any comments or suggestions.
So with this, we are at the end of the podcast. So I express my gratitude towards Dr. Deepaknath Tandur for making his time in this busy schedule and sharing his great experience and knowledge. We learned a lot from you, sir. Thank you very much. Uh, I also thank everyone in the meeting to make this podcast a success.
Yeah, yeah, wish you all the best. It was nice talking to all of you and discussing with all the students. So yeah, wish you all the best with your podcast series. I'm sure you can do well. So take care and stay curious. I would just say, and stay open-minded. It will always help you. Okay, good day, guys.
Thank you, sir.
Bye.
Thank you,
Thank
sir.
you, sir.
Bye.
Thank you, sir.